Hello, today we're going to actually use a better formula for finding binomial probabilities. We looked at this problem last video, and let's find the probabilities. A couple has 5 children. A mother has type O blood, the father has type A blood, and it has a 25% chance each kid will end up with type O blood. What's the probability that exactly 2 kids end up with type O blood? 2 kids, and the distribution is right here. Actually, I'm going to go through and do all of the kids. Now, the probability of type O is 0.25. So the probability of not type 2, our failure, will be 0.75. So if all of them fail to get type O blood, so that would be 0.75, and since there's 5 kids, that would be to the 5th power. Now, there's going to be nobody that's 0.25, and we don't have to multiply that by anything because that's a 1 on the outside. So we just take 0.75 to the 5th. And likewise, on number 5, we're going to, the probability one person has it at 0.25. If everybody gets that success, 0.25 to the 5th, and we got. All right, now the ones in the middle are the ones that are trickier. Now in this case, we're going to have one person with type O blood. So I'm going to have 0.25 to the 1st power. But there's going to be 4 people that don't have type O blood. So I'm going to do 0.75 to the 4th. Now this would just be one arrangement. If there are 5 values, there's many ways we can arrange it. Now, if we use Pascal's triangle to figure out how many ways, we could work our way down to the 5th row and get 1, 5, 10, 10, 5, and 1 for all those values. So this, we did a 1 times the first one. Now we're going to multiply 5 times this next one because there's 5 different ways we can arrange O and not O. Let's just say A. So if I have 1 O and 4 A's, there's going to be A, O, 5 different ways I can arrange that, and so on and so on. So that would be the equation where I would get one person. Now to get 2 people with type O blood, I have to multiply it by 10. That's the next number. Now 0.25, 2 people have type O blood. That means 3 people do not. I multiply those together, and then I would have this probability. To find 3 people, I go to the next number, which is 10. We have 0.25 to the 3rd, and 0.75 now to the 2nd. Now our last one, to have 4, we go and we're multiplying by 5. 5, 0.25 to the 4th, 0.75 to the 1st. Now we just plug these in our calculator and we'll get the distribution for each of the values. I'll do the one that they tell us to do here. They said, let's find the probability of exactly 2 kids. That's this one. So that would be 10 times 0.25 to the 2nd. Move this down. So then we have times 0.75 to the 3rd. So we have plug that in, and that's 0.2636. Let's just say about 26% of the time, or 0.26 probability, that they have exactly 2 kids out of their 5 with type O blood. Now this is the binomial distribution. N choose K, that's the number out in front, times the probability of success to the K power times 1 minus that probability to the N minus K. That's exactly what we did for each of those. Here is your combination. There's your combination, and then we have the probability of success to that power the probability of failure to the 1 minus that power, or the 5 minus 2 power. All right. So now there's a new problem. Say 10% of switches are defective. You choose 10 random switches to test them. What's the probability that no more than one is defective? So let's make a distribution. And we go 0, 1, 2, 3, and so on all the way up to 10. And it says, what's the probability that no more than one is defective? So that means we're just looking at the probability that none are defective or one are defective. So the probability that x equals 0. Now the zeros are the easiest ones because all of them are effective. So that's going to be 0.9 to the 10th power. Now the probability that x equals 1, now we can use our probability. Now I don't want to do my Pascal's triangle out to the 10th row. So what I can do is I can just do 10, choose 1 on my calculator. So I'm going to type in 10, math, probability, NCR 3, and choose 1, and that's 10. So I'm going to multiply 10 times the probability I get a defective, which is 0.1, and we're going to have 1 that's defective. So that means we've got to have 9 that are not defective. So to find this probability, I do 10 times 0.1 times 0.9 to the 9th. And I get 0.3874. And I didn't find this probability over here, I probably should. 0.9 to the 10th. That one's also 0.3486. So I just take those two probabilities from these two, add them up, and this would be about 0.735, something like that. So about 73%, 74% of the time, you'll have either 0 or 1 defective units in that system. All right, and we use the calculator, and we should be good. Good luck with your on your own.